Hey all, welcome back. This is going to be our 4.4 video, but first we must do a bell ringer. Remember we found our molar masses of potassium peroxide and silicon dioxide on a previous slide, so flip back for that, trying not to recreate that once. Go ahead and hit pause here, and we'll meet you down at the notes. All right, for this section, we definitely need a calculator. This is not something that you could probably mentally do. We're going to be using that exponent button on our calculator, so a scientific calculator will probably be beneficial, although we will not use our periodic tables for the most part today. All right, so today we are covering moles to particles and particles to mole. So kind of in the last video, I alluded to the fact that in chemistry, they wanted to keep amounts of substances kind of similar and kind of keep them related to each other, and it was based on the number of particles. The person that came up with this was our friend Avogadro. Amadeo Avogadro, he did a lot of work, and he came up with the number of particles in 1 mole of a substance. So what that is based on is we say that 1 mole of any substance has this many particles. That's actually something that's based also on our periodic table, right? We know that 1 mole of, let's say, carbon, right, just for randomness, 1 mole of carbon has a mass of 12.0107 grams. But the other thing that it has, this equivalent statement that Avogadro came up with, is 6.022 times 10 to the 23rd particles. So there are that many atoms. Also, if I have 12 grams of carbon, I have 6.022 times 10 to the 23rd atoms of carbon, which is a lot. All right, that's quite a few there, so it's kind of a hard number to fathom, but it makes sense because our particles are so small. So our particles, the other thing about particles is that we have a very specific label to label them. When we have an ionic compound, type 1 or type 2, we're going to use the word formula units. That's our label for formula units. When we have covalent compounds, right, we're going to use the word molecules to label. And then when we have a single element, we are going to use the word atoms. All right. So the other thing about this is not only the calculation, but we have to label it correctly as well. It's going to be very similar to what we just did. The biggest factor is we have to use that exponent button on our calculator. So I'll try to hit that as we go as well. And let's jump in here. So how to convert 2 moles from particles. We're going to multiply by Avogadro's number. 2 particles from moles. We're going to divide by Avogadro's number for the most part. Well, not for the most part. What we're using as our equivalent statement today is 1 mole of any substance is equal to 6.022 times 10 to the 23rd. And remember, it's those particles there. So this is our equivalent statement. The other thing about this equivalent statement is it is present on the back of your periodic table. Avogadro's number down there, 6.023 or 6.02 times 10 to the 23rd items per mole. So you can also find that on your periodic table in case you have forgotten it somehow. So let's go ahead and take a little peek here. All right. In this first question, it says how many moles are in 1.2 times 10 to the 24th molecules. That molecules tells us we have a covalent compound. All right. So please note that. All right. When we see molecules, we think covalent compound. All right. So on to the next thing. So we are always going to start with what is given to us in the problem. In this case, it is that 1.2 times 10 to the 24th. And we've got molecules. Unfortunately, there's not really a way to shorten molecules down, unfortunately. All right. And since we have molecules, we're going to put Avogadro's number on the bottom and 1 mole on top there. That way, what do we have? Water. All right. This way, molecules cancel. Now remember, the key here is typing this in. Try to blow this up without losing it. When we type this in, we're going to put 1.2. And remember, we're looking for that E button. Most of the time, it's like an EE button. Depending on what you're using. Like for me, I'm using a TI. I'm going to hit second. And then like mine's the X to the -1 button. Some of us have that second comma. But we're looking for the EE button. But it's going to show up as a big capital E on our calculator when we type it in on our calculator display. Then we hit 24, then we're going to divide by 6.022 E again, and then 23. So take a couple of seconds and type that in. Please follow along on this because it is very important. Otherwise your exponents will be off and you'll miss kind of every problem, which is not what we want. All right. So when you type this in, you should come up with, and we're keeping 2 decimals, you should come up with 1.99, and our label on this is moles because that right there. All right, so please take a second, type that in, make sure you come up with 1.99, and there's no exponent behind it. All right. Also a note, if you come up with like e to the negative 46th or 46th or something like that, you're also wrong. We're never going to have something that big. So please, 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 please double check that. Okay. All right, let's try again. This time we are looking for moles again, and we have 4.76 times 10 to the 22nd formula units. So that means we have an ionic compound. This formula unit's ionic compound. All right, which makes sense because it's iron 2 chlorate, right? That Roman numeral. So let's go ahead and plug this in again. So we're going to say 4.76 times 10 to the 22nd formula units. Abbreviation for formula units, I go form. All right, units. Okay, then we have 6.022 times 10 to the 23rd. That's Avogadro's number. We're going to put form units there. All right, and 1 mole on top. Again, our bigger issue here is making sure we type it in our calculator correctly. So we're going to type in 4.76, that E button, 22, and then we're going to divide by Avogadro's number, 6.022 E, 23, right? And type that in. Let's try that. We should get a number less than 1. All right, and we should get 0.0, and we'll keep 2 there, 0.079, and we have moles of Fe, parentheses, ClO3, parentheses 2. So fairly simple so far, right? All right. Let's keep rolling. This time we're given moles of water, and we're looking for molecules, okay? So we have 0.5 moles of H2O. And we're trying to get to molecules. All right. So we'll put 1 mole on bottom, the H2O. And then we're going to put Avogadro's number on top. And then we have molecules. Again, not a real easy way to abbreviate. To type in 0.5 and then multiply by 6.022 E23. All right, this one we are going to have an exponent, which makes sense since we are multiplying by an exponent, and we're going to get 3.01. And you can even say e to the 23rd. I'm okay with that. All right, but we should say 3.01 times 10 to the 23rd, and this is molecules because we are dealing with a covalent compound. Okay. And there we have it. If you want to put H2O on there, you are welcome to, but it is up to you. All right, and last but not least, this time we're going to do the same thing. We're looking for formula units of iron 2 chlorate, and we have 3,000 moles. So we'll start our little T-chart. 3,000 moles of iron chlorate, iron 2 chlorate. And we know that 1 mole of iron chlorate, right? And we've got Avogadro's number on top. All right, and we're ready to calculate. So let's type this in and make sure we have the same thing as the answer. And you should get 1.81 times 10 to the 27th. This is a pretty big number, formula units, which makes sense because, well, we had 3,000 moles. Okay, awesome. See you on the next one.